What are system, surroundings, boundary, and thermodynamics? Imagine you're watching a pot of water boil on the stove. You see the water inside the pot, but everything outside that pot also matters. That's where understanding the ideas of system, surroundings, and boundary comes in. These are key to figuring out how energy moves and changes in thermodynamics. A system is the part of the universe you decide to focus on. It could be just the water in the pot or the entire pot and water together. Basically, it's whatever you want to analyze. Think of it as your main subject for studying energy changes. The surroundings are everything outside your chosen system. If your system is the water in the pot, then the stove, the air around it, and even you are part of the surroundings. It's everything that can interact with your system. The boundary is what separates the system from the surroundings. It's like an invisible wall or a physical surface that keeps the system contained. For example, the walls of the pot are the boundary. Sometimes, the boundary can move or change shape, like a piston in an engine. How the boundary handles heat and matter is very important. If heat flows into the system, it can cause the water to boil. If matter crosses the boundary, like steam escaping, that also affects the system. Boundaries can be fixed and rigid or flexible and movable. In a closed system, no matter can cross the boundary, but energy like heat or work can. Think of a sealed container where heat can enter or leave, but the liquid stays inside. An open system allows both matter and energy to cross the boundary, like a cup of coffee with steam escaping. An isolated system is a perfect idea where nothing crosses the boundary at all, like a thermos that keeps heat in or out. Boundaries can also be classified by how they transfer heat. A diathermal boundary allows heat to pass through, like a metal wall. An adiabatic boundary does not let heat pass, like a well-insulated container. Understanding these parts is essential when applying the first law of thermodynamics. This law states that energy cannot be created or destroyed, only transferred or changed form. When you analyze a system, knowing what crosses the boundary helps you track how the system's energy changes. For example, when you push the piston down in a cylinder, work is done across the boundary, changing the internal energy of the gas. So, to sum it up, the system is what you study, the surroundings are everything outside it, and the boundary is what separates the two. Knowing how energy and matter move across that boundary helps you understand how the system's energy evolves over time. This framework makes applying the first law of thermodynamics much clearer and easier to follow.